Hello everybody, welcome back to the final part for our tutorial series on the game Geometry Dash. Last time we should have added color to the floor and to the back, as the back is also a parallax background. So this week we will finish up the whole series by adding particles, music, and the final gameplay. So what we want to do first is up in the game scene, create a new node called Particles CPU Particles 2D. So what this is basically a particle that runs in a 2D environment on the CPU. And you can name it diode effect, something like that. So now on the right, you can see there's a lot of settings, but you won't see anything happening. So first, you want to zoom in. You can see that there are little white squares falling down. And over here, we can adjust everything. So for example, if we want more of these, we can do 100, like that. So now there's more. Now here, in time, we can see one shot means it only runs once. So like we click it once, and then it turns off, which we want. So it turned one shot to on. And now change settings like explosives to 0.92, something like that. So it releases everything at once, making it look like an explosion. Then make randomness 1 for both of lifetime and explosiveness. And then you can change lifetime to 1 or anything you want, which dictates how long the particle exists for before it disappears. Going to emission shape, change the emission shape to a sphere. This way it releases the sphere. And then change the direction down here to 180 so that it goes in all directions. And then go to gravity and turn gravity to 0. This way it doesn't fall down. So now if you play this, you can see it just forms there and then disappears. The reason is that there's no actual velocity. So now going down all the way to initial velocity, change velocity to 300, and then change velocity random to something like 0.5. So now when we play it, you can see it explodes like that. However, it's very small, so what we want to do is come here to scale and change the scale amount to something like 4 and change the scale amount random to 1. So this way the sizes are also random, but they also scale up like that. But now if we want to scale the whole thing together, we can also go down here to the transform scale and we change this to like 5 on both X and Y. So now it should be much bigger, so once we play it, it's like that. So these are the settings. So once we have this, we also want that if we play this, we can notice that the particles are actually white. Instead, you can make it somewhat clear by going to color, which is under scale. You can change the color to something you want, or you can just do to something that's just clear. So we can do RGB in alpha, so it's all clear, like that. So now once we play it, so it's too clear. You don't want to make it too clear. You can just do alpha like 90 or something like that. Not the game. So it's saying if you turn emitting to on, you can see now it's semi-clear. So don't change alpha all the way to 0, but do something like 87, around that range. So now it's a bit clearer. Let's change this like 150 maybe. That looks a bit better. So now that this is done, what we want to do is going to the script of the player. So open the player script. We can see on kill body entered. Here we emit a signal and then queue free the node. What you want to do is we get the parent node first. Then we want to get the node diode effect, which is what we just created. We want to set the position to our position. And then we want to get the parent node again. get the no died effect. And then we want to set emitting to true. Or you can just do the emitting equals true. Now if you play this, so if you play the scene, once you get hit, it should now explode like that. So now that we have this, we want to add some particles to the back of the player as the player is moving. So what we can do is go into the player scene. So not in the main game scene, go to the player scene, add a new CPU particles 2D again. And now just change some of the settings to whatever you want. And I'll give you some of my settings if you want to copy them. So make sure you copy my direction, as this ensures that it goes out the back of the player. So copy this direction and spread. Now, as usual, turn off gravity. Then make sure you have some initial velocity so that this thing actually move. And then down here in color, I'm going to make it something like green to match our player character. And now going to transform, make sure you put the position as 30-30 and then scale it up a bit. So it should look something like this. Now if you go to the 2D scene, you should be able to see, never mind, this is supposed to be -30 like that. That's interesting. Why is it? Make sure we change the color to something like this. Not sure why it's going so slow, but in the game it should work as normal. So make sure emitting is on so it starts to play. So now, going to the code, we also need to change the angles and directions of this particle so that as the player rotates, the particles don't rotate with it. So what we want to do is go into the physics process, get the node CPU particles 2D that we just made, and we set the rotation to be our negative value, the player's rotation times -1, like that. And then we get the node again, and we set the position to be the original vector, which was -30, rotated by this negative angle again, like that. Now when we play, we can see the particles there, but it seems to be emitting very slow. Let me see. But that seems to work. now it seems to work, so that one seems to be broken for some reason. Put the transform to negative 30. 30 again. Now make sure you scale it up also. So it shows something like this. So once you play the scene, you should see that it emits and then, oh, we died before we jumped. But it also emits while we're jumping, which is not what we want. We do not want it to jump while in there. Let me reload this. So what we can do is go into the code. We have the two functions in player, which is the is on floor, where it sets is on floor. So while it's on the floor, we can set the emitting to be true. Like that. Then while it's not on the floor, which is on floor goes false, we set emitting to false. Like that. So now when we're in the air, now when you're in the air, it should not fall or jump. Let me see. This seems to be broken. CPU particles 2D. So the get node works. We try to set emitting function. Wow, you should set emitting to be false. Now if we play this, let's see if this works. Now it works. So as you can see now, while the player's jumping, no particles actually emitted until the player lands. Like that. So now that we have all this, we can finally add music. So going into the main game scene, add an audio player, audio stream player, don't do audio stream player 2, do audio stream player. Then add two of these, both on the main game scene. Name one death sound and the other one music. Here for the death sound, open up the audio folder and go to, where is it? Sound effects. In sound effects, there should be explode 11.mp3. You can drag it in. Here you have to adjust the volume to something that's not 0, like 10. Then here, make sure you have looped as off. So that's what it sounds like. Make sure you have loop as off. In the music, choose any of the songs. Let's do this one. And now make sure you have loop as on for these. Then change the volume to something along, whatever you want. That. So that's the music. So now going to the player script, turn on autoplay for music like this. So make sure you have autoplay enabled for music. Now in the player script, on the player died function, you want to get the node music and stop it. And then we want to get the node death sound. Then we want to play that. Now we can use the yield function to create a timer. With the timeout function, this waits for the death sound to finish, and then it should stop the death sound. And then we should replay the music like this. And once you play this, so the music plays right at the start, but once the player dies, the death sound plays and then the music replays again, which is what we want. So now all we have to do is add back spawning the player. So what we can do is up here in the variables, make a variable called player scene and preload the player scene, which should pop up as player.tscn. So now at the start of the game, it preloads the scene into the variable player scene. So now, once we replay the music, we can spawn in the player again. So we make a variable called player. We get this player scene, we instance one of the scenes. We also want to set the name to player so that we can access it in the code. Then we can add the child to the root game node. So we can add child player. Now we set the player's position to be whatever you want at the start. So currently it was around 500, 450. Then we want to set live equal to true. Now we want to get this node player, and we need to reconnect all the signals. So we need to connect died with ourself with the function player died, which we made. And now we also need to get the canvas label you died and set the visibility to equal false. So once you have all this code, you should be able to play the game. And the game should look like this. But once we die, you get respawned like that. If you find that the death sound's playing again, you can tweak this value bit to be something like slightly less of 1.3 would work. So now there should be no more explosion sounds right at the start of the game. Maybe 1.8 would work. About 1.7. Now, the game is basically done, except we have one more thing we can add, which is the background. We can switch the background colors as the game progresses. So to do this, what we want to do is go into the script. Here, we can make a variable up here, which we store all the data for the background colors. And here it is a vector. So now here we can put some values. So we're gonna structure this as this. So it's background colors, it's an array. We give it a position. So we first give it a position. So it's an array of arrays. And each array has a position, which says where we should switch the color of the wall, and the floor. So the color of the floor comes next. And then we have an interpolation distance. such that, so once we have this interpolation distance, the player, it takes time for the player to, for the scene to actually change the color so it's a smooth transition. So, well, I'm going to copy over some values I already have, which is this, not that. So this, as you can see, it's called background color. The first array here, it's position 0 because at the start of the game, has a vector 3 for the wall color and then the floor color. And then it has interpolation of distance of 0 because it should start right away. The next position is at 5,000. Then as a wall and then floor color, interpolation distance of 1,000. Then at the end, just add an array of just a very large number like that. So what these distances mean is that if you go in this image here at 5,000, it should switch colors, and it takes whole 1,000 units, so to 6,000 for it to fully switch. So you can copy these values or create any of your own. So it's position first, then the wall color in vector 3, floor color in vector 3, and then interpolation distance. Once you are done with this, to add the actual switching colors, you want to first actually come here in the ready function and add this function. So what this function does, it first gets a sprite, which we made as the background, and it sets the shade. We get the material, and we set the shader parameter color, which we made, to be the background color, which is this. Now we get the node floor, and we set the material to the shader color, background color 0, 2. So it gets the first array in this array, and then gets 1 for the floor, for the wall color, and 2 for the floor color. As you can see, in these shaders, we have the color attribute, like that. So now that once this is done, it should set the colors for whatever this is. So let's say I want to make this a very red level. Actually, it's very blue right now. So test. Since currently the floor is pink, however in the code I set to blue. Now let's see if we play the game whether the floor is blue. As you can see, the floor is now blue. So now that this works, what we want to do is coming here into the process function. If alive, we can do all this stuff. So first, actually, we copy all of this code, put it down here. So once the player respawns, so that once they respawn, it resets all the color also. This isn't really necessary, however, it's best if we do that. So now, for the big chunk of code, I'm going to put not that. So this code runs in the process function, so every frame while the player is alive. I'll briefly explain this code, but I won't go too in depth as it is fairly complicated, so you can just copy down. But first we create the variable index, and now we loop over the length of the background color array, which is this, and we see if the position, so we get each array, and we get 0, which is the position, and we see if this position is greater than the position of the player. If so, we set the index variable to be this value minus 1, and then we break out this loop. So what this does, it finds the array that's right before the player's position. So for example, if the player position was 4,000, it would go to this, which is 0. If it's 6,000, it would go to this. So now it gets position.x. So if the background color index 0, which is the position of this index, plus the interpolation distance, if it's already greater than the position of the player, then we don't need to interpolate that at all, and we can just set the position, set the colors to be what they are, like this. However, if it's not, so we use an if else statement, then we lerp or interpolate the values in between. So this is the lerp value, which is basically how far the player is from this initial position divided by the interpolation distance. And now we set the shader parameters again, except this time we need a lerp between the index before and the index here using the lerp function. So what this does is if we're at position, let's say 5,500, you'll see that we're within 5,000 and 6,000. So therefore we need to interpolate between this position and this position for the wall, and this position for the floor. So once you have all this code copied, you can see that we changed position at 5,000, the color. So 5,000 is roughly here. So let's see if this actually works. As you can see, it changed from blue to purple over here, which is exactly what we want. So now we have all the music, we have all the color backgrounds, we have all the actual gameplay. You can polish this game as much as you want. You can add a bigger level, you can have multiple levels using UI, you can add different music, you can adjust all the colors in the script. So I hope you guys enjoyed this tutorial series on the game Geometry Dash, and make sure, as usual, to leave any questions you have in the Discord. Thank you for watching.